Okay, so we've been learning about naming chemical compounds, and so far we've learned how to name molecular compounds. So the next thing would be to go to ionic or acids. But before we start that, there's a really big important topic that we need to know because it's part of both of these, and that is naming polyatomic ions. All right, so if we remember, polyatomic ions are ions. That means they're charged. They have a different number of protons and electrons total. But instead of just being one atom making up these ions, there are many atoms. So you should remember this from previous videos or reading. And we have this sheet here that tells us a lot of these different polyatomic ions. Like, for example, a polyatomic ion made from a boron with 3 oxygens with a -3 charge, which means 3 extra electrons, is named borate. So at first, we can just look them up, but this information here needs actually quite a bit of discussion. So we actually have 3 videos on polyatomic ions and how to construct their names of just the ions here before we want to get back to using those ion names in an ionic compound or using those ion names to figure out an acid name. So we're going to take a big diversion for 3 videos and do naming polyatomic ions. So the first one, we just want to focus on these polyatomic ions on top. So if you're just looking at the polyatomic ions on top here, then there we go. That's fine. You could just look them up. But you'll notice something unique about them, or I don't know if it's unique exactly, but a feature that they all share is they all have an ATE ending. And that's distinct because that allows us to change that ending and change what ion we're talking about. So one is called borate. Boron with 3 oxygens with a 3 negative charge is called borate. Carbonate is carbon with 3 oxygens with a 2 negative charge, a different charge. Silicate is silicon with 3 oxygens, 2 negative charge. Notice they don't all have 3 oxygens though. Some of them have 4 oxygens. Some of them have a -1 charge. Some of them have a -3 charge. Some of them have a -2 charge, -1 charge. So anyway, the first thing to do is memorize these, because then after we memorize those ones or learn about them, we can use those names to change them, to change the ending to ITE or add an extra prefix to change how many oxygens are on those ions. And that goes from what we have right here, which is 12 ions, to you could add per to all of them, that's another 12. Change the ending to ite, that's another 12. Or add hypo to the prefix, that's another 12. So this set right here isn't just 12 ions. 12 ions with 3 rules makes a total of 48 ions that are discussed here. So we have 2 videos to talk about that. We'll start with a quick, clever way to memorize these if you're interested. And I definitely recommend this, even if I let you have this sheet on the exam. Quick recall of these things makes every question easier. So I promise it's worth your time to at least bear with me on this video and learn this quick memorization technique so that you can recall these quickly. The first thing I want to show you is that these names here are laid out as they are on the periodic table. So if you look here, these are the noble gases. So if you ignore them, chlorine, bromine, iodine, change color pen, chlorine, bromine, iodine, chlorine, bromine, iodine. And the next column over, so this is like column 17 on the periodic table. The next column over would be column 16. Under oxygen is sulfur, selenium, tellurium. So this is where this little square here is where fluorine is at. It's not part of this system. This is where oxygen is at. Under that is sulfur, selenium, tellurium, sulfur, selenium, tellurium. Then the next one over from oxygen is nitrogen, nitrogen, phosphorus, arsenic, nitrogen, phosphorus, arsenic, carbon, silicon, boron. So this looks like your periodic table, and there's a reason for that. There's a clever little method for memorizing these that we call the T43 method. we say that if you look at your periodic table and you make a T here and a 4 here and a 3 here, then you can use that as a quick and simple way to understand how many oxygens are on each ion and how many are on its charge. Or, sorry, what its charge is. 1 negative, 2 negative, or 3 negative. So the way we do that is first, we copy those elements over from where they're at on the periodic table. I'll go ahead and do that in black. So I'll start here at the top. We'll just go across boron, carbon, nitrogen, and then that would be oxygen and fluorine, but we don't do anything with them. Then down from there, next would be silicon, phosphorus, sulfur, chlorine, then arsenic, selenium. Oops, I got off. I'm going to start this over. Boron, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, arsenic, selenium, bromine, tellurium, iodine. All right, so we'll start with the T. Well, actually, sorry, we start with the 4. 4 is the easiest place to start. So where that 4 is, those are all of the ones. If you notice, that 4 would be phosphorus, arsenic, sulfur, selenium, tellurium. Phosphorus, arsenic, sulfur, selenium, tellurium. All have 4 oxygens. 4, 4, 4. So the 4 right there represents 4 oxygens. O4, 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 O4. The T up here and the 3 all have 3 oxygens. Now that we've done that, we just need to track the charge. So for the first part, the 3 and the 4, they follow where the 3 is here, chlorine, bromine, iodine, they follow the column. So we know that things in the 17th column would tend to have a -1 charge, then -2, then -3. The 3 and the 4 go -1, -2, -3. So we go -1 for all of these, 2 negative, and then 3 negative. And where you drew that T, boron, carbon, nitrogen, silicon, those all start over. -1, -2, and -3. So that's a quick way. If you look at your periodic table, then you can figure out how many oxygens a certain ion is going to have if it ends in ATE. So these are the ones that end in ATE. So if you were to see something that you weren't really familiar with, selenate, it has the ATE ending, then you would say, well, it's selenium, it's the ATE ending, that's part of the 4, so it has 4 oxygens, and -1, -2, -2 charge. 4 oxygens, -2 charge. Because you know how the T43 method works. And a lot of people on there, when they get to their exam, would just write a T43, or maybe you'll mark up your periodic table like that. And I recommend doing that regularly. So that's actually the activity. I'll put instructions below this, but the activity is to practice this, grab a periodic table, write T43, copy it to another paper, just like I did, so that you become familiar with what the ions look like that end in ATE. So that's it. You can rewatch this video and just do it along with me, and then you'll report how you did in the answer below this.